So in our last lesson, we saw how to find the names for ionic compounds, but I left out transition metals. And I told you that names never have numbers in them. Well, remember that when we name transition metal ions, we have to include the oxidation number, which means that we have to figure that out from the compound because we wouldn't have simply the charge written when we see a formula. Okay, so we have to be able to find that compound. Okay, so how do we find the Roman numeral for a transition metal? Well, you're going to remember that when I had a compound, let's say that I had iron 3, right? I took this Fe3 plus and I had a chloride, so a Cl minus. Remember that I took this 3 from the iron and I drop it down here to the chlorine. Okay, and then the invisible 1 from the chlorine and brought it over here. So this would have been FeCl3, which means that this 3 right here on the other side of the chlorine, I can bring it back up to the iron to find that oxidation number. Now there's a few tricks along the way that we have to keep an eye out for, but basically that's all there is to it. So in my first example here, I have copper, which is a transition metal, so I'm going to need a Roman numeral. Okay, I can take this 2 from the nitrogen and bring it up here to that copper. Right? And I would call this copper 2. Okay, and now I come over and I name my anion, my N. Okay, it's an element with no extra O's after it, which makes it means that I'm going to need to end it in an IDE. Okay, if you want to check, if I bring this 3 back up here, is that the correct oxidation number for nitrogen? Yes, it is. So I would call this nitride. Yep. Okay. Similar here, I've got my silver here, and I need an oxidation number. Well, there's nothing here, right? Which means that I would have brought it up here, and there would have been just a plus without a number. So that means that this was originally silver 1. Because it had a 1 plus. Again, we can check this. Was this originally just a negative number? It was indeed. Again, element with nothing after it means that I'm going to end this word in IDE, so we call it chloride. Okay. I got an extra one here for in a second. Okay, but what if I've got polyatomic ions? I can do basically the same thing. Remember, it's this 3 outside the parentheses that would have come from the iron. So I'm going to take this 3 from outside the parentheses. This 4 was originally part of this SO4. Okay, so I'm going to bring that back up there and say that it's iron 3. Okay, and then this SO4, if I look on my list, I'll see that it is called sulfate. Okay, so let's look at this one over here. Remember that I took the 3 from outside the parentheses and brought it up. Well, I basically need to do the same thing here. If I don't have parentheses, I really need to put them back. Well, now it's an invisible 1 that's outside of this parenthesis, right? And I'm going to bring that back up here. This 3 is not from the silver. It was simply part of the nitrate itself. So you have to put the parentheses back if you've got a polyatomic ion here, right? We took the 3 from outside the parentheses. We need to take the number that's outside the parentheses. We took them away earlier, but we're going to put them back for now. Okay, it brings that plus up there. It makes this silver 1. Okay, nitrate. Okay. This last one here, do basically the same thing. I'm going to put this here. I'm going to take this number from outside the parentheses, okay, and bring that up. Okay, and that would have been a plus. But I want you to stop for a second and look at this CO3 and come over here. Well, if I took this number, this invisible 1, and brought it back up here, I would just end up with a negative charge on my carbonate. But if you come over here and look at the carbonate, it has a 2 minus charge. Where did that 2 go? in order for this 2 to have disappeared, it had to have been reduced. So there had to have been a 2- here, which means that this was originally a 2+. So this is not chromium 1 as it looks when I pull this number up, but this is indeed chromium 2. Okay, carbonates. Because that came off my list here. Okay, so to recap, things you need to watch out for. You need to pull the subscript on the anion back up to find the Roman numeral, find the original oxidation number of our transition metal. Okay, keep an eye on your polyatomic ions. You're always going to pull the number from outside the parentheses. So if the parentheses aren't there anymore, you have to put them back first and then pull the number up from outside the parentheses. And then keep a close eye on when we reduced those oxidation numbers, okay? Because sometimes we end up with an invisible 1 here or maybe even a 2, not because it is a 2 here, but because it got reduced with the other number. The other thing to watch out for is that you don't have to do this for absolutely every compound. You only have to do it when you have a transition metal. So if you have something that says MgCO3, okay, we don't have to care about what the oxidation number of the magnesium is. We can just call it magnesium carbonate, which I don't have room for. Okay. And you'll see that this one should have been a 2+. Magnesium has a 2+ oxidation number, and this was a 2-. They reduced too, but we just don't even care. We didn't have to watch for that. The only time you have to fight this battle to figure out what the oxidation number on anything is when you have a transition metal. Okay? Good luck.